Hey, in this tutorial we're going to have a look at solving trigonometric equations. So this is something that we've got to get good at, okay, because it's definitely going to be on the exam and most likely on a SAC or two as well. Okay, so this is where we're going to start using our knowledge of the unit circle and exact values to solve these type of functions. Okay, so our first one that we're going to look at is solve cos theta equal to a half for theta being between 0 and 2 pi. Okay, so that's a pretty typical sort of question and a pretty typical domain as well. Okay, so that's once around our unit circle. Okay, so the first thing we need to do is go, what's our basic angle? Okay, so that is when this cos, or whatever's on this side, okay, equal 1 on root 2. Okay, for cos, that is pi on 4. Okay, so look for that basic angle. Then we say cos is positive, okay, in which quadrants? And for this it's going to be the first and fourth quadrants. Okay, remember, cast. Okay, so first and fourth quadrant. Okay, now at this stage we can equate anything that's inside here, in this case just theta, okay, to our solution. So in our first quadrant, that is our basic angle or our reference angle. Okay, that's the one in there. Okay, so that's our pi on 4. Okay, and then in the fourth quadrant we need to think, okay, how do we find our angle? Well, it's 2 pi minus theta, or in this case pi on 4, or minus our basic angle. Okay, so then we get our answers of pi on 4 and 3 pi on 4. Okay, so we look for our basic angle. We might need to do some work first. We look for our basic angle, okay, work out when it's positive, okay, or negative. Okay, in this case it was positive. We had a negative there. We would have been saying cos is negative in the second and third quadrants, okay, and we would be in a different process. Okay, and then work out what our values are in the appropriate quadrants. Okay, for the second one we've got solve tan theta equal to 1 for negative pi to pi. Okay, so this one can be a little bit trickier. Okay, so again we do the same thing though. We say our basic angle, okay, is again pi on 4. Okay, now we need to think about this domain a little bit more. Okay, but we'll still be able to look at when tan is positive. So tan is positive. Okay, again, think of our unit circle, cast, okay, in the first and third quadrants. Okay, so we're looking at the first and third, but we've got to take care of this domain a bit. Okay, so in the first quadrant, so really, what this domain's meaning is we're measuring angles from here around to here. Okay, that's our pi. Okay, in the positive direction. Okay, and we're also measuring angles this way. Okay, negative pi. Okay, so we know we've got a solution here. Okay, and over here still. Okay, so this one is fine. Okay, and we're going this way, we're only going to get one solution in there because we've got to stop here. Okay, so we've got theta is equal to our pi on 4. Okay, then we really need to say, we've got to come around here and say we're also going to be negative pi plus pi on 4. Okay, because we're going to be coming back this way. Okay, so we get our theta equals pi on 4 and negative 3 pi on 4. Okay, because we're going to measure this way. Okay, so there's two problems. Now, both of those ones are somewhat straightforward. Okay, I've got two more here that are a little bit more complicated, okay, and are probably a little bit more likely to be exam style questions. Okay. So you can see it's looking a little bit more complicated now. We've got 2 sine of 2x, take 1 equals 0. So the first thing we need to do here, before we find our basic angle, is just rearrange things. Okay, so we're going to say that we've got 2 sine of 2x equals 1. And so sine of 2x equals 1 on 2. Okay, we've got to get to that stage. Okay, so now we still look at our basic angle. Basic angle, when is sine equal to a half? Okay, but it's going to be pi on 6. Okay, and sine is positive. We have a little unit circle cast in the first and second. First and second quadrants. Okay, but we've got to take care of these two here. Okay, now what we do is we actually multiply the domain by 2. So we're now looking for solutions from 0, and if you like, we can put 2x, okay, up to 4 pi. Okay, because we weren't just looking for x. Okay, if x is between 0 and 2 pi, then 2x is going to be from between 0 and 4 pi. Okay, so we're going to get more solutions. Okay, and the way to remember this is, for a normal trig function, we always expect 2 solutions. So we multiply that number by our coefficient here, in this case 2. 2 2s are 4, so we're expecting 4 solutions. Okay, so now we've got a little bit of work to do. So now we can say we've got 2x, okay, is equal to, now we need our angle in the first quadrant. That's our basic angle of pi on 6. Okay, then we need our angle in the second quadrant. And remember, our second quadrant is pi minus our basic angle of pi on 6. Okay, and pi minus pi on 6 is 5 pi on 6. Okay, so I'll make that 5 pi on 6 now. Okay, but we've only come all the way around. We've come from here around to there. So we've gone from 0 to 2 pi. That's where we currently are. We hit a solution there and hit a solution there. The thing is, we'll come around again. Okay, but the bonus is that when we look at this solution, we've only got to add 2 pi onto it and we get around to it again. So with this one, we add 2 pi and we get around to it again. So what we do is we go pi on 6 plus 2 pi and 5 pi on 6 plus 2 pi. Okay, so then we get 2x equals pi on 6, 5 pi on 6, okay, and then 2 pi is really like 12 pi on 6 if you like. So then we've got 13 pi on 6. Again, we think of this as 12 pi on 6, so it'll give us 17 pi on 6. Okay, which is all well and good, but remember, we need to be in our 0 to 2 pi range. But we haven't actually taken care of this 2. So now we can divide all these by 2, which is nice and straightforward because it's multiplying our denominators by 2. So we get x equals pi on 12, 5 pi on 12, 13 pi on 12, and 17 pi on 12. Now remember, with a base of 12, 2 pi is equal to 24 pi on 12. Okay, so you can see we're back inside our original domain now. Okay, so the key different step here is we need to multiply our domain by this coefficient. Okay, to expand our domain and get our solutions till our domain is full. Okay, that's really important. Okay, our next worked example here that we've got, okay, is root 3 cos of 3 pi plus sine of 3 theta plus sine of 3 theta equals 0. And we're from 0 to 2 pi again. Okay, so what we need to do with this one, okay, is we need to do a little bit of work to get this going. Okay, and what we actually need to do, okay, is we need to divide everything by cos. Okay, which might seem a bit odd, but then what we get is root 3, well, cos of 3 theta divided by cos of 3 theta is just 1, so it drops out. Plus sine of 3 theta over cos of 3 theta. Okay, and of course 0 divided by cos is still 0. The reason why we do that is, of course, because sine on cos is tan. So we end up with root 3, so tan of 3 theta. Root 3 plus 3 plus tan of 3 theta equals 0. So then we get tan of 3 theta equals negative root 3. Right, now we can start working through our problem. Okay, so we need our basic angle. Basic angle, when is tan equal to root 3? Remember, ignore the negative, root 3, that is 4 pi on 3. Okay, and then tan is negative. Okay, if we leave our cast over here, okay, so tan is positive in the first and third, so negative in the second and fourth. Second and fourth. Okay, now we need to multiply out our domain by 3 this time, so we're going to be going from 0 up to 6 pi. Now, you'll never have to go higher than 3. Okay, they're getting awfully harsh if they ever ask you anything higher than 3. Okay, so now what we need to do is, again, we can say, well, 3 theta is equal to, well, now we know that we're actually in the second and fourth, we're actually not using that first quadrant this time. So we're not just going to be whacking our basic angle. Our first one in the second quadrant is going to be pi minus pi on 3. Okay, and our fourth is 2 pi minus pi on 3. Now pi minus pi on 3, that's just 2 pi on 3. I'll just replace that. Okay. Now 2 pi we can think of as 6 pi on 3. Take pi on 3 is going to leave us with 5 pi on 3. So ditch that. Okay, it just makes it a little bit easier because now we can do that process of adding 2 pi to it. So we need to go around again, okay, just like we did over here. So we've got 2 on 3, so it should be 2 pi on 3 plus 2 pi, 5 pi on 3 plus 2 pi. Okay, but we've got to keep going because remember we need 6 solutions. Okay, so really we then need 2 pi on 3 plus 4 pi because we've got to go around again, and 5 pi on 3 plus our 4 pi. Struggling to fit in, 4 pi. Okay, so the other thing that you could have done is worked out these 2 solutions, then added 2 pi to them. Wouldn't have mattered too much. Okay, so we're going to get 2 pi on 3 still. 5 pi on 3. Okay, again this is equivalent to 6 pi on 3, so we can make that 8 pi on 3. Okay, and then again that's like 6 pi, so that's going to make it 11 pi on 3. Okay, now again we can keep working this up, so I'll just keep adding on, so it will be 14 pi on 3. Okay, and then we're going to be 17 pi on 3. Okay, of course this is 3 theta. So well and truly outside our 0 to 2 pi range. Okay. So again we've got to divide by 3 now. Okay, to get back in our domain, so we need to multiply all these denominators by 3. So we get 2 pi on 9, 5 pi on 9, 8 pi on 9, 11 pi on 9, 14 pi on 9, and 17 pi on 9. And of course 2 pi is 18 pi on 9, so we're inside our original domain. Okay, so there's just one more type of question that we need to look at. I forgot to pre-write a question, but we'll make one up now. Okay, so what we need to be doing is looking at one more question where it might be something like 2 sine of 2 theta minus pi on 3 equals 1 for 0 to 2 pi. Okay, so we just need to be careful with ones like this, okay, because if we're not, okay, this is going to come back and bite us and we're going to miss out on solutions. Okay, with ones like this where we've got a translation, you don't necessarily have the same number of solutions as you normally would. Okay, so what we'll do is start off like normal, we'll just rearrange a little bit. So I end up with sine of 2 theta take pi on 3, right, equaling 1 on 2. Okay, so our basic angle, when sine is a half, is pi on 6. Okay, and sine is positive, okay, in the first and second quadrants. Okay, so now we've got to take care of this domain stuff again, okay, which is a little bit trickier this time. So what we need to do is we want to times it by 2, okay, but then we want to actually take away this pi on 3 as well. Okay, so we're going to say then that we're negative pi on 3, 2 theta take pi on 3, okay, up to, it would be 4 pi minus pi on 3. Okay, now 4 pi is really like 12 pi on 3. Okay, so take pi on 3 is going to be 11 pi on 3. Okay, so that's why our domain would actually be. Okay, so now we need to find out where our solutions are going to really come from. Okay, and think about where we're going. Okay, so starting at minus pi on 3, okay, which is going to be down here. Okay, and then we're going to go all the way around. Okay, and then we're going to go all the way around again to here. Okay, so it's really 2 loops around, but we're starting here and finishing here. Okay, now fine, it's not actually going to make any real difference with this one, but it can with some of our other ones. Okay, so now we'll go through our process like we would. Okay, so we're saying 2 theta minus pi on 3, okay, is equal to, now remember we're first and second, so we're in here and here. Okay, so the first is our basic angle of pi on 6. Okay, second one is pi minus pi on 6. Over here, remember that's pi minus pi on 6, which will give us 5 pi on 6. Okay, now what we're going to do is we're going to add on 2 pi to both of those. Okay, which will give us 13 pi on 6 and 17 pi on 6. Okay, so what we need to be careful of when we've done that, okay, is that we're still inside our domain here. And we've got all of our solutions. So the times that it can become a bit tricky, like we won here, is if we were, say, looking at cos. Okay, and with cast, okay, cos is positive here. Okay, so it just depends on where our angle was. So we could have been, say, looking at pi on 6. Okay, so we could have had a root 3 on 2. Okay, so we still would have been looking at our pi on 6. Okay, but our translation of pi on 3, okay, we would have had a solution here. Okay, but if we had a say a pi on 6 in here, and sorry, a pi on 6 translation here, sorry, yeah, in there, but a basic angle of pi on 3, well, we could have been looking at a number here, but it's been outside the domain. So it can just be a little bit tricky. So you just need to be a little bit careful about whether they're inside or outside the domain. Okay, what we need to do here is now get all these right because of our translations. Okay, so say 2 theta. Okay, now this is really 2 pi on 6 if you like, just to make it easier. We need to add that to everything. So now we're going to get 3 pi on 6, okay, 7 pi on 6, 15 pi on 6, okay, and 19 pi on 6. Okay, and now we're going to divide it all by 2. Okay, 3 pi on 12, 7 pi on 12, 15 pi on 12, and 19 pi on 12. Okay, and you can see all these ones are nice in our range there of our domain. As I said, I should explain it a little bit better. Okay, we might have had, okay, a solution here that gave a basic angle of, say, pi on 3. Okay, we would have been over here somewhere, okay, for our pi on 3. But our translation was a pi on 6 here, which can change things around a bit. Okay, we might have had this solution not being included, okay, in our lower end, say. So we just need to be a little bit careful there. So look, hopefully that's enough to get you through some of these questions on solving equations. As I said, it's something that's definitely going to come up on exams and most likely on SACs as well.